Hey guys, welcome back. So we're going to do a video today going over some of the manufacturing considerations of actually building this. So like we mentioned in the last video, we actually do want to sell these when we're done. And also, like I said, I don't think I'll sell a ton of them, but this is almost like for practice. So this is pretty much, this isn't the first product I've done, but this is going to be the first one that I actually made myself, like from the ground up. So in this case, I'm buying material and it comes in. Basically, they just, it's a piece of bar stock and they chop it off with a saw. And I just have these round discs that show up. Hot rolled, heat treated 4140. And we're going to take that raw material and turn it into a finished product, a billet main cap. So I'm going to show you guys how we're doing this and what we're trying to do. So, like I said, I've done stuff, I've made a lot of parts. I mean, I've probably made, 1,000 parts on my machine. A lot of them are duplicates. But I've never made something where it actually needed to be efficient. It's usually just one-off stuff. So with one-off parts, you kind of take your time and knock out the job. But in this case, I would like to make, hopefully hundreds of these or thousands of these or something. I don't know, a bunch. And for that, it needs to be efficient because I want to sell this. And like I mentioned last time, you got to be efficient. You got to get it done quick. Can't run up the bill with time or, materials. So let me show you how much has went into this. Man, where do we start? All right, first, let me show you a little bit of the numbers. Okay, so this is my Excel sheet, and you'll notice we have 4 different versions. We're going to start with 1, and I'm going to quickly kind of skip around and get to version 4. So with version 1, what we did was we opened up an Excel sheet, and we said, hey, here's the steps we got to do. So step 1 is basically marking where we're going to take the mill scale off, and when we get to the bottom, we're cleaning it, oiling it, and putting it in a plastic bag so it's ready to ship. Now what we did was up here, we started tracking our time. So we tracked our human time and our CNC time. We also had a column for what tool we're using, and then right at the end we added a things to make this happen column, which as you can see is mostly empty, but we put a few things in there. So anyway, this is kind of how we started off, and this was a good start. And as you'll notice, here's what we ended up with. We ended up with 35 minutes of human time and 116 minutes of CNC. So you're looking at just over half an hour in basically 2 hours. Now that's to build one cap, not a set. So when you add that up, that's 3 hours of human time and 10 hours of machining. And let's see, there's a couple other caveats worth noting on this. So with this data, what I'm not including is all the tool changes and fixture setup changes that will have to happen. Now there's a reason I'm not doing that, because the hope is that if you're making a lot of parts, that'll be a low total amount of time. So say it takes you 10 minutes for every setup to change, and you have to do that, say 10 times, that's 100 minutes. But if you're making a lot of parts, that gets divided out and it'll only be a few minutes per set of parts. That's the hope, at least. So for now, we're going to ignore it and just look at it on a part-by-part basis. But here's the numbers. Now let me take you to the other versions real quick. So we're going to go to version 2. And here's what you'll note. This sheet, if you just back up and take a 30,000 foot view at this looks a lot more organized. You can see we got the labels are improved and there's more detail, and you see I have 2 different columns. I have sorry the focus sucks, things to do to make this happen and how to speed it up. And for the how to speed it up, when we got done with this list, we actually went through and said, hey, let's try to think of one thing we can do to speed up every single step on this piece of paper. And so one thing you'll notice, on version 1, we had 51 steps. When we got to version 2, we actually had more steps. And that's because we kind of realized we made some mistakes, like, hey, we left some stuff out. So we added some steps, but check this out. We go to version 1, we were at 35 and 116. Now we're at 30 and a half and 100. So we did say, even though we added a few steps, we actually shaved some time off. And we did that through a few different things. Basically, we went through this how to speed it up, and some of this stuff we're not doing, but we did think of a few things, and hey, we'll take everything we can get, right? So let me show you one of the biggest things on here. You see, here's the human time. You'll note, let's see, actually maybe you won't note. I already changed it by this. No, I didn't. Here it is. Cut 2 parts off with horizontal bandsaw. You'll see, I actually put that as CNC of 10 minutes and a human time of 2 minutes. So that's basically the human getting the saw set up and letting the saw do the cutting. And that's what made the big difference on the human time for this. Is before we were using a portable bandsaw. Back in version 1, you'll see it just says cut it off a bandsaw, And there's 8 minutes because I was doing that by hand with a handheld portable bandsaw. So I changed that on this one, and that saved a little bit. But we really started thinking about this, and we're like, we'd really like to knock that number back. Let's see, so when we got to number 3, we still had it in there. But I'll get to that in a second. But on 3, we're at 30 and a half and 100. And then here's version 4. Now I've been working on version 4. This is version 4. Man, have I got some work in this. You guys have no idea. Hours and hours and hours. And I mean, there's probably 20 hours in this sheet. Just what you're looking at. Actually, it's more than that. But here's what we ended up with. 19 and a half minutes of human time and 88 minutes of CNC time. This is the most important one, the human one. We got essentially 20 minutes of human time per cap. So that's 100 minutes for a set. That's an hour and 40 minutes. We're under 2 hours of human time to make a set of caps right now. And like I said, this ignores fixture changes, and I'm sure there's errors. But hey, we're looking at about 2 hours. That is awesome. We were at a way bigger number than that before. So, huge improvement. Huge. I can't stress that enough. This is one of the make or break things for this product. And let's see, I think we actually knocked it back. Yeah, so remember we started going up in steps. By the time we get to the end, we'd actually reduced our number of steps. And man, we did so many things. I'm going to show you the Fusion side. I use Fusion 360 for my CAD and CAM. It's pretty awesome software. If you guys ever want to get into that, man, they got some, it's nice. It's a good setup. But let me show you what we did. So you'll note up here, it says remove part from vise, clean the part, install it in vise, and start roughing. We hit op 2. Op 1 was cut the rectangle to clamp in a vise. That's all machined now. We're not doing that by hand. We're not even using a saw. So this is kind of a funny story. So at work, it's a cheapie, but they have a Harbor Freight horizontal bandsaw. And my boss and everybody that works there, they're real nice folks. They let me use their bandsaw. And I agreed. I ended up buying a new blade for them because I broke their other one. Anyway, I did tear up their saw blade, to be fair, but I left it. It now has a better blade than when I started, and it's brand new. Anyway, these gentlemen let me use their saw, and I started cutting. And to be honest with you, I had all kinds of trouble with the saw because it just Harbor Freight. However, it did cut metal. But what I realized was I was sinking way too much time into it. Basically, my thought was if their saw worked great, I was just going to buy one myself. That was the thought. And I was like, okay, I'll just buy this saw and, it'll take me 5 minutes to cut a part or 4 minutes or whatever. Well, I actually did get the cut time down to 5 minutes a cut. But the problem is I was averaging an hour to cut 2 parts. And the math doesn't add up, and that's because the saw sucks. I could never get it going smooth. And I worked on their saw for probably, 3 or 4 hours total, trying to adjust things and make repairs and swapping out blades. Broke 2 different blades working on this thing. So basically in the end I determined that it wouldn't be feasible to buy a Harbor Freight bandsaw and use it. So instead we're just going to machine all that material off using end mills and cutters. And there's actually pros and cons, right? The pros are we save human time because the machine does the work. The downside is more machining time, which isn't so bad, but more tooling costs because now we're going to wear out more tooling. So it does add to the cost of the bearing, but it saves us time. And frankly, that's just a worthwhile compromise at this point. So it's like, okay, that's cool. But you'll note here, there's all kinds of things. So you'll look, we have a 3/4 indexable end mill, and then you see it repeats 2 times. This is one of the only spots we really got to do that, where we got to use the same tool for multiple operations back to back. So you'll note here it says perform op 2, perform op 3, perform op 4. Maybe I need to go back. Okay, so is it 3? Sorry, I kind of screwed this up. 2 and 3 use the same tool. And they also have the same offset. So we were able to skip removing the part from the vise, cleaning it, and installing the part in the vise. We did that for 2 to 3 and 3 to 4. So that definitely saved us some time there. And then our tooling, for better or worse, you'll see we start off using this 3/4 indexable end mill. Then we swap to a 1 1/4 indexable end mill. So anytime we're using an indexable end mill, these have inserts you can change. So this is kind of like an affordable way to machine stuff. Then you'll see we have a short drill bit and a long drill bit. Then we have what's called a 3/8, this is a 3/8 4-flute end mill. Then we go back to our 3/4 indexable and our 1 1/4 indexable. Then we have a 3/8 reduced neck. This is a specialty tool. I just found this one today. Man, I should show you guys this tool. This took a long time to find. Yeah, let me show you that one real quick. Okay, so this is that particular tool. And it's not exactly like this picture, but it does look kind of like this picture. So what you'll see is this thing looks ridiculous. It's stupid long. So this thing has a cut diameter of 0.156, 5/32, so pretty small, a little over 1/8 of an inch. But you'll see the overall reach is 2.375 inches. And what it doesn't tell you here, but this total length from like here all the way to here, that's 4 inches. So what you can do is you can grab the tool, like say back here with like an inch, and you got 3 inches poking out of your machine. Yeah, it's just this thing here doesn't have all the dimensions. But so the downside is these cutters are $50-something a piece, and that's without shipping. And I don't know what it is with end mills, but man, these guys charge you like, you pay 15 or 20 bucks every time you want to. This cutter can weigh half a pound or a quarter pound, and you'll pay $20 for shipping. It's stupid. But anyway, we're gonna need this. So 2 of these plus shipping, easily gonna be $120. Yeah, plus tax, probably $130 and this just does one tool for one operation. But it's just kind of how it goes. This is actually what we used to do the helical. What's that say? Helical bore? Oh yeah, sorry, I just showed you the wrong tool. Okay, all that tool I just showed you is actually one down here. This one, a couple steps down, the .156 stupid extended length. Actually, it's that one. This is a different specialty tool that's 3/8 reduced neck. That tool actually costs more than the one I just showed you, but it does look similar, except it's 3/8 instead of 156. But anyway, some of these ops required specialty tools, and there's a reason we're doing that. Essentially, these specialty tools make the job easier. So you have to pay for the tool, These tools are expensive. You could just use a drill bit that costs $10. But from my standpoint, I need to be able to build caps without drama and without issues. And that's what this does. This helps me make caps repeatably without issues. And I'll show you that in the cam in a few minutes. Then you'll see here we drop down, this is operation 12, which is to cut the distance between the flats. So this is a critical dimension. So we mentioned this in another video, but basically the very last thing we do is we're going to set the distance between the flats. This is the registers that go in the block. And then we're going to face it off flat where it goes to the block. These are the last 2 operations. So this one we're going to have a 1/2 inch stub length 4-flute finisher end mill with a coating. And a lot of cutters could do this job, but we chose this one for a lot of different reasons. So a 1/2 inch, this is a really stiff, rigid, and this isn't an insert tool. This is a sharp end mill, and it's stub length. And we're doing all this to maximize rigidity. What we want is we want to be able to machine that distance very repeatably. So if I build a cap and another and another, and I build like 50 caps, I want them to all be the same within, a very, very tight tolerance. So we got a tool that's specialty just for that task. We're not going to use this end mill on anything but this. So the goal is, even though it's a, kind of an expensive end mill, but that'll last a long time, and because we only use it for that one task. And then lastly, we use this indexable to do our facing. And for this, we'll have new inserts. So as you'll note, some of these cutters get used in different places. So in cases when they're doing roughing, they can use any insert, but like in this, where we really care about that surface finish, we'll have new inserts. We put in the tool for that. But yeah, this is what we've been working on, this crazy looking Excel sheet. Like I said, ton of work went into this. But the organization, so this is kind of what's making this possible for me, is I'm going through and putting down all my thoughts on every single step. So, we ended up with about 50 steps right now. I'm sure we're missing 1 or 2 things I just left off. But there's a lot of steps in this, and we're really being methodical about this, going through and saying, like, hey, how do we speed stuff up? It's like, okay, one of these said only do 1 pass instead of 2. It's right here. We actually made that change, I believe. It was just the way things are programmed. I found a better way to machine it. You'll see some stuff on here is like, hey, I have an air gun and a coolant hose to clean and rinse stuff off. I haven't done any of that yet. There's all kinds of ideas on here. And a lot of the stuff we still got to do. But these are all things we're thinking about. And this is pretty important. It's kind of like the idea of continuous improvement. You got to go through and keep trying to make stuff better. And for me, I really wanted to get this down to about 2 hours of human time. Almost because I know it's going to get worse. Usually things like this get bigger. So we want to do everything we can to keep this quick. So yeah, that's kind of our all of our planning, what we came up with. Like I said, we ended up with 13 different operations. And I know this isn't finished. I got to go back and change a few things here and there, but we've basically worked on this for 2 days straight, and this is what we ended up with. We actually have a more workable plan. You know, this has got less human time and everything's faster. So hopefully this is good. We're probably going to give this a shot soon. I want to try running some of these parts. Anyway, I'll have a lot more info about this in the next video. Anyway, hope you guys enjoyed, and y'all take it easy.